Welcome to my channel. This is Grace Tutor, and what I do is solve technical drawing problems, and I provide very important information that can help you to have a better performance in your technical drawing examinations. If you are watching my video for the first time, I want to say thank you, and I want to ask you to subscribe to this channel, using that to encourage me to do more when it comes to technical drawing, and help me to share my videos with your friends who are technical drawing students. And it's very, very important that you practice this subject because this is a practical subject. So when you practice it, you become a master at it. So I want to share an information with you. As I said, I share information with students on this platform. And this information has to do with oblique projection, and I'm going to take it one by one. I think I will have about 5 or 6 information to share with you about oblique projection. And as you can see on the screen, the first thing that we'll be talking about here is oblique axis. Oblique axis. When we talk about oblique axis, so we have 3 oblique axes, and starting from this particular drawing that we have here, we have the horizontal axis, we have the vertical axis, and we have the receding axis. So the horizontal axis is this one that we have here, and the angle between the horizontal axis and the vertical axis is 90 degrees, okay, as we know that before. Then for the receding axis is at angle 45 degrees to the horizontal. So this line is the receding axis, and the angle that it makes with the horizontal is 45 degrees. So that means it also makes angle 45 degrees with the vertical axis. So as you can see here, that this is a right angle triangle. So we have taken 45. So the balance here from this line A to B is also 45 degrees. But mind you, as I said, that the receding axis makes an angle of 45 degrees with the horizontal axis. So as I said, so we have 3 oblique projection axis. We have the horizontal axis, we have the vertical axis, and we have the receding axis, which is at angle 45 degrees to the horizontal. Now let's come to this particular diagram that we have here. So this information that we have here is also important for every technical drawing student, especially when it comes to objective question in WAEC, that is West African Examination, or National Examination Council, that is NECO, or any exam that you want to do that has to do with technical drawing or engineering drawing, where you'll be writing objective questions or providing answers to objective questions, you need to have this particular information. Okay, so let's look at what we have here. So we look at this line that goes to X is the horizontal axis, and as I said, it makes an angle 90 degrees with the vertical axis. So it makes an angle of 90 degrees with this vertical axis that goes to Y. So what about the line that goes in the direction of Z? So what about if you are given a question and this is represented with X, with Y, and with Z? So as we know that if this is where we put Z, so the angle between vertical axis and horizontal axis is 90 degrees. So then what about this angle here and this angle here? If you look at the angles that we have here, this angle for angle 135 degrees, that means the horizontal axis makes an angle of 135 degrees with the Z-axis, and also the Y-axis makes an angle of 135 degrees with the Z-axis. So let's make sure we pay attention to that part and we bear that in mind. Okay, so let's go to the next one. So we are going to talk about the types of oblique projection here. Types of oblique projection. And as you can see on the screen, we have 2 types of oblique projection. We have cavalier projection and we have cabinet projection. And as I've said, so the receding axis is put here. As you can see, this is the said receding angle. It means that the angle that the receding axis makes with the horizontal axis is 45 degrees, as I've explained before. Okay, so this is a receding axis or receding line. This is also a receding line, and this is also a receding line. Now, if you look at this diagram very well, you will see Now they said the length is full scale or full size scale. The length is full size scale. So that means in the cavalier projection, the length of the receding axis is drawn full size. So if the length of the receding axis or the receding line is 60 millimeters, you need to draw it 60 millimeters. So it means that in the cavalier projection, we draw the receding axis, we draw it full size. We draw it full size. So though this face that we have here, it is parallel to the horizontal projection plane. So this face, we leave it as it is dimensioned. We leave it as dimension as we have here. Likewise, the receding axis is also drawn full size scale. It is drawn as is given in the diagram. But what is different between cavalier projection and cabinet projection? So let's talk about the cabinet projection. As you can see here, in the case of cabinet projection, we draw out size of the receding axis or the receding line. So as we have in this cavalier projection, we have the length of the receding axis or receding line to be 60 millimeters, but when it comes to the cabinet projection, we draw it 30 millimeters. But every other dimension remains as we are given. It remains as we are given. If you look at this, from here to here is 60 millimeters in cabinet projection, and we still have it here at 60 millimeters in cavalier projection. And then from here to here, we have 60 millimeters in cavalier projection. Here in cabinet projection, we still have it at 60 millimeters. So if you look at all these dimensions that we have here, they remain as they are given in the original drawing. But the receding axis is drawn half full size, So we divide it by 2 and we make it 30 millimeters. If the receding line as we have here is 60 millimeters, so from here to here is 30 millimeters, from here to here is 30 millimeters, and from here to here is 30 millimeters in the cabinet projection. So let's pay attention to that part to know the difference between cavalier projection and cabinet projection. Now let's move to the third one as we have here. So we want to talk about oblique angles. Oblique angles. So we have 3 oblique angles. An oblique block can be drawn to any of these 3 angles. That is angle 30 degree, angle 45, angle 60 degree, and angle 45 degree as we have here. So that means we can use our 30 degree set square to draw an oblique block or an oblique object. We can also use the 60 degree side of our set square to draw an oblique block or oblique object. Then we can make use of 45 degree to draw the oblique block or oblique object. But most times, as you know, we make use of 45 degree set square. Why? Because we want to reduce the distortion. So let's start from here for the 30 degree. So the distortion cost here by using 30 degree is more than when we use 45 degree. And the distortion caused by when we use 60 degree is so much high than when we make use of 45 degree set square. So that's why we often make use of 45 degree set square. But mind you, as I said at the beginning, we can draw an oblique object, oblique block to any of these 3 angles, 30 degree, 45 degree, or 60 degree. So that's what I want to bear in mind. An oblique object or oblique block can be drawn to any of these 3 angles, as I said, 30 degree, 45 degree, and 60 degree. Okay, so and as I said, the distortion here is more in 60 degree is more high than that of 30 degree and that of 45 degree, but we often make use of our 45 degree set square to draw any oblique object. Now let's come to the fourth thing that I want to talk about here. We have talked about the oblique axis. We talk about the oblique types of oblique projection, and we talk about the oblique angles. Now we want to talk about the oblique length or receding axis. Now, as I said, that an oblique object can be drawn to any of these 3 angles, be it 30 degree, 45 degree, or 60 degree. But as I said, we often use 45 degree set square to draw an oblique object, oblique block. So there's something I need to tell you here. When we draw the object with the use of 30 degree set square, or we draw the receding axis at angle 30 degree to the horizontal, the distortion cost or the receding line is altered by 1/3 of the true length. Let me say it again. When we draw an oblique object at 30 degree, or the receding line at 30 degree to the horizontal, the receding line is altered by 1/3 of the true length, okay, of the true length. So when we draw it, sorry, that's 2/3. That's 2/3, not 1/3. It is 2/3 of the true length, 2/3 of the true length for 30 degree. But when we draw it at 60 degree, so the distortion, or the receding line is altered by 1/3 of the true length, by 1/3 of the true length. But when we make use of 45 degree, the receding line is altered by 1/2 of the true length, 1/2 of the true length. Kí ló ṣẹlẹ̀? Kí ló ṣẹlẹ̀? You want biscuit? Yeah, get up. Let me get up. All right, so let me recap what I said. I said when we make use of our 45 degrees set square to draw the receding length of the oblique object, so the receding axis is altered by 2/3 of the true length, and that of 60 degree is altered by 1/3 of the true length, and for 45 degree it is the true length, or the receding axis is altered by 1/2 of the true length. So let's pay attention to that particular part. Now let's come to number 5. As I said here, that in oblique projection, the object is assumed to be placed with one face parallel to the horizontal plane of projection, and therefore that particular face appears in its true length. What are we talking about? This face here of this object here is drawn parallel to the horizontal projection plane. Is drawn parallel to the horizontal projection plane, and if we draw a square on that horizontal projection plane, it gives us a normal square. It gives us a normal square. If you draw a circle, it gives us a normal circle. If you draw a rhombus on that face, it gives us a normal rhombus. And if we draw a rectangle on that face, it gives us a normal rectangle. So what we are saying is that the face that is placed on the horizontal projection plane gives us a true shape, or we see it in its true shape. So as we have it here, okay. Then number 6 says that keep the longest dimension parallel to the plane of projection, and this may reduce this distortion effect of the object. So when we are to draw an oblique object, it is very, very important that the longest length should be drawn on the horizontal projection plane in order to reduce the distortion. So don't forget. So when we draw the longest length of an oblique object on the horizontal projection plane, it reduces the amount of distortion that will have made if we have placed that longest length on the receding axis. Okay, so let's take note of that. Then another one is that's number 7, that the face of an object containing essential contours, that is circles and irregular shapes, must be kept parallel to the plane of projection. So what we have seen is that if there are features on this face here, it is very, very important that we draw that particular face on the horizontal projection plane. So it makes the work easy for us when we place the features like circles, like semicircles, like whole, or we have what? We have something like recess on that particular oblique block. So it is very, very important or very good for us to draw it on the horizontal projection plane. So all this information are very, very important. So I'm going to stop here. So those are the 7 important information that I have for you on oblique projection. So let's pay attention to every part and let's study it so that when the question comes in objective question, be it West African Examination Council or National Examination Council, be able to give the right answer or choose the right answer among the given options. Thank you and God bless you.